And here we are again with some notes on ions and solubility. This is page 15 in your note packet. What we're going to talk about today is a little bit about solutions. A solution is any kind of well-mixed mixture, but in this case we're talking about a liquid solution. And we're talking about different substances that we put into the solution and what happens to them. All of these things that we're talking about are going to be ionic solids. We already went through naming. We know that ionic compounds are made from a cation and an anion. Sodium, for instance, has one electron. Chlorine has 7 electrons. We know that because of where they are in the periodic table. Sodium has 1 outer shell electron. Chlorine has 7. And the sodium gives that 1 away, so he becomes positively charged. He's a cation. Chlorine gains 1, so he becomes negatively charged and is an anion. All right. That allows those to exist together as an ionic substance, ionic compound. If you have an ionic compound that is soluble in water, I'm going to start with the word soluble. Soluble means it will dissolve. It'll dissolve in a solution, in a solvent. In this case, water. What happens if it's an ionic substance? When you put that into the water, it will dissociate, which means it will break into the ions, and the water particles will surround it. Now, the only ones that will do this are the ionic compounds that are soluble. How do we know what's soluble and what's not? Well, in your notes, in your notes, of course, we have our ion chart on the back, but we also have a solubility chart on the back of our periodic table. Or in your notes, it's on the same page with the hot or not chart that we talked about with single replacement reactions. Okay, hot or not should be on page 11, and the solubility chart is also on there. Now, how do you read this? If a substance is going to dissociate in water, if it's going to be soluble in water, what that means is those water molecules will come in and surround the cations and anions and pull them apart. But how do we know? Well, we have this handy-dandy chart. If we look at the chart, it tells us that any ion, any negative ion, that is paired with someone from group 1A, which would be lithium, sodium, potassium, so on and so forth, will always be soluble. Sodium compounds are always going to be soluble. Doesn't matter, always going to be soluble, whoever they're bonded to. Same thing goes for ammonium ions. Okay? So, both the group 1A and ammonium ions, always soluble, will always dissolve in water. How about anions? Our friend nitrate, chlorate, and perchlorate, always soluble. Again, most -1 ions are going to be soluble. There's a few exceptions, but for the most part, these are always going to be soluble. I'm going to make this a little bit bigger. There, now I can see it better. Acetate, also always soluble. And now it tells you over here, silver is only slightly soluble. This is going to be the first of a trend, you'll see. But for the most part, any acetate you have. So if we went back to the chemical closet behind 203, anything that says nitrate on it, we could get it out, it'll go into water. Anything that says chloride on it, anything that says perchlorate on it, or anything that says acetate. Okay? Anything with a sodium in it, potassium in it, anything with ammonium in it, going to be soluble. Now, chlorides, bromides, and iodides are almost always soluble. But there are 3 exceptions. The 3 exceptions are silver, lead, and mercury. The way to remember this, it's a little crude, but if you think about lead, the symbol starts with a P, plumum. Mercury, the word mercury, not its symbol, starts with an M. Silver, it starts with an S. PMS. Of course, people write up ladies that are cranky to, oh, they must have PMS, right? You've all said it. You all know you have. PMS, these 3 elements are cranky. So they are not going to be soluble a lot of the time. For the most part, here on out, lead, mercury, silver are going to precipitate. And we used that word before, precipitate. It means it's not soluble. Okay? So, chlorides, bromides, and iodides, if it's silver chloride, it's going to precipitate. If it's silver bromide, it's going to precipitate. If it's lead iodide, it's going to precipitate. It'll also be a really pretty yellow color because lead forms lovely yellow compounds. Next one, sulfates. Sulfates are almost always soluble. The exceptions, PMS, silver is slightly soluble. When we did this lab in college chem, our silver sulfates dissolved just fine. But lead and mercury will form compounds. They will form precipitates. The other 3 are the big 3 compounds at the bottom of the alkaline earths. Calcium, strontium, and barium. Basically, calcium, strontium, barium, and PMS, not soluble. Everything else is soluble. So sulfates, for the most part, will dissolve. Sulfides, on the other hand, will not dissolve. Group 1A, of course, always soluble. Group 2A might be soluble, might not. Everybody else, nah, never soluble. Next one, hydroxide. Now here's the exception to that -1 rule. Most -1 ions are going to be soluble. Hydroxide's the exception. Once again, our group 1A and ammonium, always soluble. Remember the big 3 back here with the sulfates? They're going to precipitate with sulfate, but those big 3 are going to be soluble. Calcium, strontium, and barium will dissolve in water if they're bonded to hydroxide. Everybody else is not soluble. That includes PMS. PMS up here. Phosphates, carbonates, sulfates, or sulfites, excuse me, only group 1A and ammonium. Chromates, only group 1A and ammonium. Ferrocyanide, only group, or everybody's soluble, oops, I lied, except for silver and zinc, amazingly enough. And oxides, group 1 and 2A are soluble, everybody else not soluble. Oh, and look, here's your activity series at the bottom that we talked about in our last video. All right, let me get that out of here. So that is what the tool that we use to determine what will be soluble and what will not. All right, I didn't do a real good job of that, but oh well. Let's talk about some of these other, oh, that's not good. Some of these other words, definitions. Aqueous. Aqueous means it will dissolve in water. We've already defined that. Or it means it is currently dissolved in water. Soluble means it will dissolve in water, or will dissolve in a solvent. We've already defined that. I apparently erased it. Insoluble means it will not dissolve. And I'm going to put that word precipitate in here. If it's insoluble, it will precipitate. If it precipitates, we use the little s, which you would think would be soluble. But no, we use AQ for soluble. Doesn't make sense. I can't explain why. We already know what an ion is. An ion is an element with a charge. Our protons do not equal our electrons. If it's a positive charge, it's called a cation. If it's a negative charge, it's called an anion. Another term here is electrolyte. You've heard of electrolytes when you hear people talk about Gatorade. Electrolytes are salts that are dissolved in water. But the reason they are special is because they will conduct electricity. They will conduct a current of electrons. If you put salt in water and you run electricity through it, it will go through the water. If you have distilled water, though, that has no substances dissolved in it, not going to run electricity through it. When Megan Hathaway was killed in the hot tub back in the 80s on Days of Our Lives, she was the bad guy. All right, this is just coming off now. She was the bad guy. She was in the hot tub. Salem Slasher came in and dropped the radio in and killed her. If her hot tub had been distilled water, and she had showered all the salts off her body before she got in, and she didn't have any soap or any shampoo in there, she would have lived. Fun fact. All right. So, the next part of this asks, which of these compounds will ionize in water? Hit pause. Use your solubility chart. See if you can figure it out. All right. FeOH2. Hydroxide's almost always insoluble. So he will precipitate out. He would not ionize. Potassium permanganate. Potassium's always soluble. He will ionize. By ionize, what we mean is he'll dissociate. So he's going to form a potassium ion and a permanganate ion. Like that. Potassium chromate. Again, potassium. He's going to ionize. He's going to form a potassium ion and a chromate ion. Chromate's a -2 charge, so we need 2 potassiums. Magnesium phosphate. Phosphate's almost always insoluble, and this is no exception. Zinc hydroxide. Hydroxide's almost always insoluble. That guy's no exception. Ammonium hydroxide, though, ammonium is going to be soluble, so he will ionize. He will form ions, or we say dissociate. I tend to say dissociate, just so you know. Cobalt 2 nitrate. Nitrates are always soluble. He is going to dissociate. And we know it's cobalt 2 because there's 2 nitrates. Potassium iodate will dissociate. Potassiums always dissociate, so we'll get potassium and iodate. Nickel sulfate, it's not PMS, and it's not the big 3 on the alkaline earth metals, so this guy will dissociate. This is nickel 2. How do I know that? Well, the sulfate is always a -2, and there's only 1 nickel bonded with him, so he has to be +2. too far. Our last two here, lead chloride, lead PMS, it's going to precipitate. Nitrogen triiodide, excuse me, is he ionic? No. Two nonmetals. So guess what? He may or may not dissolve in water. I'd have to think about it. He should dissolve in water, probably. But he's not going to dissociate. So he's going to, when he dissolves in water, you would write it like this. All right. Thank you very much.